So we are dealing with the 7th problem in this series, and the problem is stating point charges q and minus q are located at the vertices of a square with diagonal 2l as shown in the figure. Find the magnitude of the electric field strength at a point located symmetrically with respect to the vertices of the square at a distance x from its center. So to begin with this problem, we are first of all constructing the diagram back again. So we have a situation like this as shown, where the charges are placed on the vertices of a square, and the charges which are placed over here, the first charge is plus q, another one is again plus q, this one is minus q, and this one is minus q, and the diagonal separation between them is referred as 2l. The diagonal separation between them is referred as 2l. Now at a distance x perpendicular to the center of the square, we have to calculate the electric field strength. So over here, one thing which we need to understand is that the distance x is perpendicular to the plane of the square. The distance x which the problem is referring is perpendicular to the plane of the square. The next important thing which we need to understand is that in this problem we have two dipoles. We have first dipole which is in this direction, and then we have another dipole which is in this direction. So we have two dipoles, each of magnitude p. So dipole moment of each dipole, that is magnitude of each dipole moment which we consider as p, is equal to product of charge and separation between the charge, which is over here written as 2l. So this is the dipole moment of each dipole which we are referring as p. So net dipole moment, since the two dipoles are perpendicular to each other, so we can say that the net dipole moment can be written as root 2p. So p net can be written as root 2 times of q multiplied by 2l. So this is the net dipole moment which we have for this particular system. Now at a distance x from the center, we are asked to calculate the electric field strength. So electric field due to a dipole, electric field due to a dipole at a distance x, perpendicular to the plane. So we write electric field strength E as Kp by x square plus a square to the power 3 by 2. So this is the standard result which we are using. So if we substitute the values that we have, so therefore we can say that the electric field strength E can be written as K, that is 1 upon 4 pi epsilon naught, P which we are referring as root 2 times of q into 2l upon x square plus a square to the power 3 by 2. So here we are using p net. So for each dipole, the result is kp by x square plus a square to the power 3 by 2, where we are not considering x as a large distance. And over here we have this value. So if we solve this one, so 2 we cancel it out with 2, then root 2. So we have the value ql upon root 2 pi epsilon naught x square plus l square to the power 3 by 2. Over here a is equal to l. So x square plus l square to the power 3 by 2. So this is the magnitude of electric field strength at a distance x from its center. So this is the required answer which we are looking for.